Let's now take a look at the harmonic mode. The harmonic mode uses additive synthesis. Now when I play a note here in this default setting, it sounds like a sawtooth tone we're hearing. So how is this different from, let's say, using analog mode with a sawtooth here? Well, in analog mode, we're using subtractive synthesis, where we start with this waveform, and then maybe we filter it out and shape it to create our custom sounds. In harmonic mode, what we're seeing here are individual partials, which are all unique sine waves that are stacked at different frequencies to recreate that sawtooth sound. Now you can choose how many of these partials you want. We can set the maximum here, it goes all the way up to 512. And we can limit it to, let's say, 32 if you want. And you can see here how it kind of chops off there. And we can further tone it down by removing some of those upper harmonics. And it kind of sounds like a filter. Let me go back to 256. Play an entire chord. So not exactly what a filter does, but it sounds kind of like a filter, which is turning off individual harmonics from this particular sound. Now, how is this any better than just using the analog mode? Well, because we are recreating the sawtooth by using individual harmonics, we have control over those individual harmonics. So a simple example is with this parity knob. If I move the parity knob to the left, we start to get rid of even harmonics and just keep the odd harmonics. And what we have here is a very nice square wave. If I shift to the other side, we're removing odd harmonics and keeping the even ones. Except for the very first one. Alright, what else can we do? There's a tilt feature here. Kind of tilt the loudness of the certain harmonics. So if I tilt it more to the left, kind of gradually filtering out those upper harmonics. To the right, it gets a bit loud. I'll bring the volume down here so we can hear that better. And now we're making those upper harmonics louder. There is an offset that you can add. So now we're moving somewhere in the center here, and now we can clearly see that shape that we're introducing. So tilt one way or the other way. And you can see how it's kind of centered around this harmonic. And that's because of the offset. Now this is something you just can't do in the analog domain. Alright, I'm going to reset all this. Let's check out this section here. It's kind of like a filter, but unlike any filter you may have used. So we get two filter options here. These are all the different shapes. Let's start with the left one over here. I'll leave it at this comb 1. With the morph knob set all the way to the left, we'll only hear this filter. Let's increase the depth of this filter. I'll bring the volume back up. Look at that. So this unique shape, so-called filtering shape, has been applied to this entire spectrum. Let's try the one on the right. So that is a different shape, again being applied to the spectrum here. And the reason why we can even do this is because we have control over individual harmonics. So it's just a matter of reducing the level of individual partials here. Alright, what else can we do? There's a section knob here. So we can choose to move or offset the spectrum that we're going to focus in on. Might be a bit more obvious if you had a different shape. Let's try this repeat shape. And let's move all the way to the left, so we're looking at that spectrum. So let's say I want to focus in on the lower register. So it's mainly affecting these partials, as opposed to maybe somewhere up there. Very cool stuff. Imaging. We can choose to keep just the odd harmonics in the center, or move it left or right. Same for the even harmonics. So this way, very easily we can expand on the stereo image of a sound. Even if you weren't filtering the sound. Even harmonics are more to the right versus odd harmonics more to the left. Different modes here. We're in split mode. There's also random. We have a rate and depth. Notice how it's just randomly adjusting the amplitude of different harmonics, either on the left or right channel. We also have this periodic mode. More consistent. Sine wave-like. Pretty amazing how we can just pan individual harmonics within a particular tone. Alright, let's move to the left here and talk about this window feature. I'll disable this for now. Now we've looked at this window in the sample mode. So if you go back to sample mode here, just turn on second engine, switch to sample mode and turn on the granular mode. Here we talked about how we're adding a windowing as we're repeating certain grains. In the Harmonic Engine, we have this window mode where we can choose to frequency modulate certain windows of frequencies within the spectrum. What does that mean? Remember the modulator section? So this can be used to frequency modulate a certain window of harmonics. Now in the center it's at 0. If I increase this, we're adding audio rate frequency modulation to certain partials in the sound. Now I can adjust the window size. You see that little graying area in the background? That defines the window size. We can also change the position of it. And we can adjust the overall gain of the harmonics within that window. Pretty fascinating things you can do to individual harmonics in a sound in additive synthesis. Alright, so that's window mode. Let's check out cluster. Now in cluster, we're not doing any frequency modulation. You can see that that line has disappeared. But what we have the option is to affect certain clusters of partials. So I need to increase the density for this cluster feature to work. You notice how we're moving certain partials closer to each other. And we're introducing bigger gaps between clusters of partials. I can adjust the cluster size here. I can adjust the cluster position. And you can kind of see it. It's kind of affecting these frequencies here. Or should I say these partials. When it's set at 1, it's saying, okay, I'm going to affect the very first harmonic onwards. Partials, we can choose how many partials to keep within each cluster. Right now it's set at 2, but I can increase that. So bigger clusters here. Very interesting way to affect the sound. Alright, the last mode here is Shepherd mode. So this creates that classic audio illusion called the shepherd tone, also known as the Rosette tone. Very similar deal to the other modes, so you can set a certain window of harmonics that you want to affect. You can choose how large that window is going to be, and you can choose to add gain to that window. And then finally, we can do that shepherd tone effect, which is basically creating this illusion of pitch constantly increasing or constantly decreasing. Now, by just adjusting the knob, it doesn't sound like it's constantly increasing or decreasing. To really create that effect, we will have to modulate this with maybe an LFO that's a ramp down or a ramp up. So let's set this up. I'll set the knob somewhere in the center. Let's choose the window size to be maximum, so it chooses the entire spectrum. Position is fine, because we are using the entire audio, and let's leave the gain kind of in the middle there. Alright, so I need to add an LFO to this. I'll hit the plus button here. Let's use LFO 1, maybe at about 0.5. And now I want to change the shape of that LFO. So let's do a ramp down shape like this. I'll play a higher note. It's a bit fast. Maybe if we slow this down, the illusion might be a bit more obvious. So you go, that sounded pretty smooth there. Alright, so those are the 3 different modes for the partial modulation section. Cool, so that is the harmonic mode that uses additive synthesis. With that, we've taken a look at all the different modes in the engine. Now we have 2 engines here, so you can activate both of them. You can choose any of the different synthesis techniques. You can even copy from one engine to another. So I can click over here and say copy to engine 2 or copy to engine 2 with modulations. So when I copy it over, we now have the harmonic mode over here, and we also have that modulation. Alright, in the next tutorial, we will check out this utility engine.